Hello students and welcome to my channel Maths Hub. So I, Dr. Tanya Bose, will be talking to you about Fourier cosine transforms in this video, right? So now let us see that what were the formulas for Fourier cosine transforms. So if you haven't watched the first video, do watch the first video because it will tell you the derivation behind the Fourier cosine transforms, right? So if you remember, we did the Fourier integral representation of the function f of x, and when the function is even, it gives rise to the Fourier cosine transform, right? So where we did the function f of x is equal to basically 0 to infinity a of s cos sx dx, right? And the value of as was written as 2 by pi integration 0 to infinity f of x into cos sx ds. This was done, right? Now we are just molding the formulas because I told you that as calculates the Fourier cosine transform and fx calculates the inverse Fourier cosine transform for the function fx, right? Now, if you can see that in one of the formulas in Fourier transform, we are applying the constant 2 by pi, and in inverse Fourier transform, there is no constant, right? So just to remove this ambiguity, we will multiply both the cosine transform and the inverse cosine transform with the factor under root 2 by pi so that it gets balanced, right? So if you follow different books, you will always see that there is ambiguity in these formulas due to this coefficient, right? So if you're writing the coefficient, you need to write it 2 by pi in one of them. And if you want to distribute it equally, then you can multiply under root 2 by pi. So I will be discussing by multiplying the factor under root 2 by pi because then you will not forget that where you need to keep this constant and where not to keep this constant, right? So we will be using the notation for Fourier cosine transform as fc alpha is under root 2 by pi 0 to infinity f of x cos alpha x dx, right? And similarly, the inverse Fourier cosine transform will be given by the formula f of x is equal to under root 2 by pi 0 to infinity fc alpha cos alpha x d alpha. Done? Okay. So now let's see the first question, how to solve a Fourier cosine transform. You are given the function f of x equal to e to the power minus ax. The interval is x greater than equal to 0 and you need to calculate its cosine transform. So let us see how to do it. So we know that fc alpha is equal to under root 2 by pi 0 to infinity integral f of x is e to the power minus ax cos alpha x dx, right? Now, I told you in my previous video also that whenever you have the functions cos or sine, you can always convert them into exponential functions by writing cos as real part of an exponential function and writing sine as the imaginary part of the exponential function. So you can always write this as under root 2 by pi integration 0 to infinity and e to the power minus ax will come as it is. Now what is cos alpha x? We know that it is real part of e to the power iota alpha x dx, right? I hope you know this concept because e to the power iota theta is equal to cos theta plus iota sine theta. So I can always write cos theta as the real part of e to the power iota theta, right? Now, that is the next step. I can multiply both the exponential terms together. So this will become under root 2 by pi. I can take the real part outside. 0 to infinity e to the power. Both are exponential terms, so I can take it out. The bases are same, so the powers will get added. So I'll take the negative sign common. I'll get a minus iota alpha x. And then we have integration with respect to, right? Now, very well, we can do this integral. This is under root 2 by pi, real part of integration will become e to the power minus a minus iota alpha x divided by minus of a minus iota alpha, limits from 0 to infinity, right? So now, what is this? This is under root 2 by pi, real part of Now when you put the limits, e to the power minus infinity is 0 and e to the power 0 is 1. So you will get minus 1 upon minus a iota alpha, right? So the negative sign will go and you can realize this term by multiplying with a plus iota alpha. So this is under root 2 by pi, real part of, when you multiply with a plus iota alpha, you will get a minus iota alpha into a plus iota alpha, right? So now this is under root 2 by pi, real part of a plus iota alpha divided by, you'll get a square minus iota square alpha square. So that is a square plus alpha square. Now what is real part of this term? This is under root 2 by pi a upon a square plus alpha square. So this becomes the Fourier cosine transform for the function f of x equal to e to the power minus ax. Right? So I hope you can do the integrals by this way. It will become more easy. Right? Okay. Let's move on to the next question. So the next question says, find the Fourier cosine transform of f of x equal to e to the power minus x. Now I'm not doing this question. This is a homework question for you. I'll just give you a hint. We have already calculated the Fourier transform of e to the power minus ax. So that is coming out to be under root 2 by pi a upon a square plus alpha square. So your question is to calculate the Fourier transform of e to the power minus x. That means you are substituting a as 1. So this will become under root 2 by pi 1 by 1 plus alpha square. So you can do this and check your answer that you should be getting this as your answer. Right? Okay. So we move on to the next question. The next question says, find the Fourier cosine transform of fx equal to x into e to the power minus ax, where both x and a are greater than 0. Right? Now how to do this question? Let's see. So you can write the formula for Fourier cosine transform, and that will become f of alpha is equal to under root 2 by pi 0 to infinity integral function, that is x into e to the power minus ax into cos alpha x dx. Right? Now again you can see you are getting a cos term. So you can always write it as real part of. So this is under root 2 by pi integration 0 to infinity x into e to the power minus ax into, this can be written as real part of e to the power iota alpha x dx. Right? Now we can club in the terms of exponential and we can write this as under root 2 by pi real part of, and then we can write 0 to infinity x e to the power I can take out negative sign common and I'll get a minus iota alpha, and then we have x and dx. Right? Now this is not that easy integral because it is also containing x. So you have to apply the Euler rule. So x is your first function and e is your second function. So let us apply the Euler rule. So this is under root 2 by pi. And from the entire answer, once we solve it, we will calculate the real part, right? So according to the Euler rule, we keep the first function as it is, that is x. Then integration of the second term, that is e to the power minus a minus iota alpha x divided by minus a minus iota alpha, limits from 0 to infinity, minus, then derivative of x is 1, integration, again integration of this term. So the integration of this term will become e to the power minus a minus iota alpha x divided by another term will come here. So I'll get a minus iota alpha whole square, and the limits are from 0 to infinity. Right? So here I am applying the shortcut rule for Euler. In the shortcut rule of Euler, whenever there is an algebraic function, you can keep the first function same and you can integrate the second function. Then alternatively, you will put plus and minus. Then take the derivative of the first function and integrate this function again, right? So this is how you'll get this step. So now this is under root 2 by pi, real part of. Let's put in the values of the limits. Now when you put infinity here, e to the power minus infinity will become 0. So 0 into anything will become 0. And when you put 0, x will make it 0. So this term will always contribute 0 to your answer. So this term will always contribute 0, right? So now let us take this term. Now in this case, e to the power minus infinity will become 0 and e to the power 0 will become 1. So you'll get minus 1, but there is already a minus sign outside. So you will get 1 upon a minus iota alpha whole square, right? Again, you need to realize this term. So we will multiply with its conjugate pair. So we will get a plus iota alpha whole square divided by a minus iota alpha, a plus iota alpha, and then we will take a square here, right? So now this is under root 2 by pi, real part. And what is, when you open it up, you'll get a square plus iota square alpha square. So that is minus alpha square plus 2 iota a alpha divided by a square minus iota square alpha square. So that will become a square plus alpha square whole square, right? And now when you take the real part out from this, you will get under root 2 by pi. The real part is a square minus alpha square divided by a square plus alpha square whole square. So this becomes a Fourier cosine transform for fx equal to x into e to the power minus ax. Right? Okay. So I'm taking all the difficult questions so that you don't face any problem when you solve these exercises, right? So there is one more. So now let us try to solve another question. So I'm taking up all the difficult questions here. So this question also has a different technique, right? So we need to calculate the Fourier cosine transform of fx equal to e to the power minus x square. So let us apply the formula. F of alpha is equal to under root 2 by pi. So I can write here fc alpha and then 0 to infinity integral e to the power minus x square into cos alpha x dx, right? Now, whenever we have e to the power minus x square, that integral becomes difficult unless it contains an algebraic terms x along with it, right? So how to solve these integrals? We try to convert this integral into a differential equation and we try to solve it, right? Now, when we convert it into a differential equation, since this integral is with respect to x, we try to solve it with respect to the other variable, right? So the other variable is alpha, which is free. So we assume that let us this integral be named as I. So let us calculate di by d alpha. Now when I calculate di by d alpha, I'll differentiate with respect to alpha. So e to the power minus x square is not disturbed. Now what is derivative of cos alpha x with respect to alpha? It would be minus sine alpha x into x. So I will get x into sine alpha x dx, right? So in the next step, I can take out minus common out. We will get under root 2 by pi integration 0 to infinity x e to the power minus x square into sine alpha x dx, right? Now how to solve it? We will apply the Eilert rule. So according to the Eilert rule, we will assume sine alpha x to be the first function and let us assume this as the second function, right? So this is now minus under root 2 by pi. Let us apply the Eilert rule. So sine alpha x is same. Integration, I'm just working out the integral here. Integration of x into e to the power minus x square dx. So what is integration of this? You can put x square as t or you can put minus x square as t. So you will get minus 2x dx is equal to dt, right? And then this integral will become minus x dx will become dt by 2 and this will become e to the power t dt by 2. So that is simply minus e to the power t by 2. And the limits will be from 0 to infinity. So you will get the integral as e to the power minus x square divided by 2, limits from 0 to infinity, minus integration 0 to infinity. What is the integral of sine alpha x? Derivative of sine alpha x, that is alpha into cos alpha x into integration of the same term. So you will get again e to the power minus x square by 2 dx. Right? Now, how to solve it further? Let us put the limits here. E to the power minus infinity is something 0, and sine at infinity will take a finite value between 1 and minus 1. So the upper limit will give us value 0. And from the lower limit, again sine 0 is 0, so this term will become 0. Right? So the first term will always contribute 0 in your answer. So accordingly, we will get minus and minus will become plus. Under root 2 by pi is already out. Alpha can be taken out. 2 can be taken out. Right? And now we are left with the integral 0 to infinity e to the power minus x square cos alpha x dx. Right? Now, according to the given question, so what is this? This is basically alpha by 2 into the integral I. If you take under root 2 pi, along with this integral, it is the simple integral I, right? So here we had di by d alpha. So this will give us di by I is equal to alpha by 2 into d alpha. So this is a variable separable form. You can easily integrate it, and we will get log of I is equal to 1 by 2. Integration of alpha would be alpha square by 2 plus a constant c. So from here, I can write the answer as I is equal to e to the power, I can write it as c times alpha square by 4. Isn't it? Right? Okay. Right. I think there would be a plus sign here, because when we integrate this term, there's already a minus, and when you integrate this term, there is again minus of e to the power minus x square by 2, right? So you will get a negative sign here, in fact, a negative sign here, right? Just make these corrections. So you will get I is equal to c into minus c alpha square by 4. Now, how to solve it further? Let us put alpha equal to 0. When you put alpha equal to 0, what is your I? I is e to the power, or you can also write this term instead of writing it as c. We can write it as log c, and we can also, instead of taking the constant in an exponential form, I can write it as c times this term, right? So when I put alpha equal to 0, e to the power 0 will become 1, and I is equal to c. Is there any chances of calculating I from any other source also by putting alpha equal to 0? Yes. You can put alpha equal to 0 here, and you can get I as under root 2 by pi integration 0 to infinity e to the power minus x square cos alpha will become 1 dx. And we know that this is the gamma function from the error function, right? And this will and this has value equal to under root pi by 2, right? So under root pi will get cancelled, under root you will get 1 by under root 2. So I is 1 by under root 2, and I is also equal to c. So that implies c is equal to 1 by under root 2. So if you put it back here, so I turns out to be 1 by under root 2 times e to the power minus alpha square by. So this becomes the Fourier cosine transform of fx equal to e to the power minus x square, right? Little typical, you have to frame the differential equation first. And by framing the differential equation, you'll get the differential equation in this form. It gets converted to a variable separable form. And then by putting alpha equal to 0, you can calculate the value of the integral from both the cases. And then you'll get the value of the constant, and that will lead to the answer. right? So I hope you understood the topic of Fourier cosine transform. So thank you so much. Believe in yourself and you will definitely do it. And subscribe my channel to get the latest updated video. Thank you so much and have a nice day.